in the right orientation. Okay, so we're doing 10-5 today, but this worksheet goes along with a different textbook. So 10-5 is actually right here. So it's these two theorems that we're doing today. We are talking about tangent lines, and the tangent line is a line right here that touches the circle at one point. In a plane, a line is tangent to a circle if and only if, there's a typo here, the line is perpendicular to a radius of the circle at its point of tangency, which is what it's looking for. So, point of tangency. So the point of tangency is right here. It's where that line intersects with the circle. So this right here, point of tangency. And this theorem states that from the center, the radius here is perpendicular to that tangent line. And then we have tangent segments theorem. What this means is that this tangent, if from the same point, and this tangent are the same length. So this is the same length as this here. Tangent segments from a common external point are congruent. And that's it for the theorems. Now we're going to practice it in the workbook. So we're going to go to 10-5. You'll get to do it in class. Okay, determine whether each segment is tangent to the given circle and justify your answer. It wants to know if segment HI is tangent to the circle. If it is, then this here would be perpendicular, making this a right triangle. So we're going to use Pythagorean Theorem to determine if this is a right triangle and if that is perpendicular. So a squared plus b squared equals c squared. We have a, b, and c. And then we'll plug it into the Pythagorean Theorem. 9 squared plus 40 squared equals 41 squared. 9 squared is 81. 40 squared is 1600. And 41 squared, if you plug that into a calculator, you'd get 1681. So 81 plus 1600 is obviously the same thing. So since it works out, then yes, HI is tangent to the circle. And number 2, it wants to know if this line is tangent to the circle. If it's tangent, then this would be a 90-degree angle. You can kind of visually see that it's not quite a 90-degree angle, but using the Pythagorean Theorem, because a lot of times these aren't to scale to begin with, we do need to check it and see. And 16 plus 144 is 160. That does not equal 169, so no, AB is not tangent.
Is that all we're doing?
We're going to go through the different examples, but yeah, the lesson stays pretty simple. Number 3, find x. Assume that segments that appear to be tangent are tangent. Round to the nearest tenth if necessary. Okay, so here we have a tangent line and a tangent line. They go from the same external point, so therefore they are equal in length. And we can set those expressions equal to solve for x. So 3x minus 6 equals x plus 10. Yep, x equals 8. Quite a few people absent today, including. Yeah. There's also testing. They might be in testing. Number 4. Number 4, same idea. These are assumed to be tangent lines, and if two tangent lines are from the same external point, then their length is equal. So 4x plus 2 equals 2x plus 8. And we can solve for x. Number 5 is similar to number 1 and 2. It's saying that FG is your tangent line, therefore it should be perpendicular to the radius, and we can use Pythagorean Theorem to find x. So this would be your A and B, and then your hypotenuse for Pythagorean Theorem. So 8 squared plus x squared equals 17 squared, and we can solve for x. Equals 289. X equals 15. Of course, make sure that's logical. That side should be less than the hypotenuse. Number 6.
I actually got a decimal, 18.78.
The square root of 225.
Hold on, you may have done something wrong. 17 by 17 is 289.
Correct. Minus 64.
64 is A and B.
And I think I did. If you see it, let me know. But number 6, same idea. This should be perpendicular. So we're going to do 24 squared plus 10 squared to find x squared. 24 squared, 576, plus 100 equals x squared. Take the square root of both sides, and x equals 26. Okay, number 7 and 8 are a new type of problem, same kind of concept, just a different way it's presented. Remember, when you have that external point, the tangent lines are going to be equal in length to the circle. So just focusing on one part at a time, we're going to solve for x, and then we're also going to find the perimeter of the shape. So here, this has to be the same length as this segment. So 2x equals 9. So x must equal 4.5. So that's part of the answer to the problem. Then they also want to know the perimeter of this triangle. So each of these are an external point and a tangent to the circle. So whatever this length is, it has to be equal to this length. So if this is 13, then this is 13. And then here, if this is 4, then this is 4 here. And then to find perimeter, we're going to add up all the lengths. So 4 plus 4 plus 13 plus 13 plus 9 plus 9. And we get 52 is the perimeter. Number 8, same type of problem. So if this is 13, then this is 13. What's up? If this is 5, then this is 5. If this is 13, then x equals 13. And if this is 5, then this is 5. So x equals 13, that's the first part of the answer. And then to find perimeter, we're going to add up all the lengths. 13 plus 13 plus 5 plus 5 plus 13 plus 13 plus 5 plus 5. Yep. And then we're going to move on to the back. Tori, you have to have your mask up, bud. Okay, next. Okay, I'm not going to go over every problem on the back because these concepts are pretty simple. For number 1, it wants to know if MP is a tangent line. To figure that out, you would have to do 20 squared plus 21 squared equals 28 squared. If that equaled, then it would be tangent. And I'm not going to go through all the steps. If you get that one on the homework, just solve it and see. And then this one, same thing. It would be 48 squared plus 14 squared equals 50 squared. If that worked, then QR would be a tangent line. Number 3, it's saying assume that these two segments are tangents. If they are tangents from a common point, then this length would be the same here. So 7x minus 3 equals 5x plus 1. You could solve for x, and that's all you have to do for that one. Number 4, assuming that TS is a tangent, this would make a 90-degree angle, and you could use Pythagorean Theorem to solve for this length. So 10 squared plus 15 squared equals x squared. And 5 and 6, these are set up a little bit differently than the ones on the other side, but same idea. These are all tangent lines to the circle, so if this is 12, then this is 12. So we can get my pencil working. This is 12. Here we have 3x and 18. These two sides are the same length, so we can do 3x equal to 18 and x equals 6, so that's part of our answer to the problem. And then this would equal 18. And then for this length, we can do 52 minus 18 to get 34. That's 52 minus 18 to get 34. And then if this is 34, then this is 34 here. Then to find perimeter, you would add up all those lengths. 18 plus 18 plus 34 plus 34 and plus 12 plus 12. And it comes out to 128. And number 6, a little bit of problem solving involved here as well. They give you these two lengths, which is nice. They give you the whole length here, but that's not going to help you solve for x. So let's see what we have. If this is 6, then this has to be 6 right here. And then 13 minus 6 is 7, so that must be this length. And this length would be the same as this one, so this has to be 7. And 14 minus 7 is 7, so that's this length. And then that would equal x. So x equals 7. And then to find perimeter, you add it all up. 6 plus 6 plus 7 plus 7 plus 7 plus 7 plus 18 plus 18. Number 7 is almost the same type of problem. It says that the design shown in the figure is that of a circular clock. We can see that inscribed in a triangular base. It says that AF and FC are equal. So AF and FC are equal. So if this is 7.5 inches, this is 7.5 inches. These here are tangent lines to the circle. So this must also be 7.5 inches, and so would this. And then if this is 2 inches, then this right here is 2 inches here. Now looking at the question, it says find the length of AB, so this segment here. That length would be 7.5 plus 2, which would be 9.5 inches. And then it says find the perimeter of the clock. We're just going to add up the lengths. 7.5 plus 7.5, 2 plus 2, plus 7.5 plus 7.5. And that's all. Okay, so you have the rest of class to get your homework started. You'll probably finish it. If you finish it, get started on Khan Academy. Of course, if you have questions, let me know. And that's it.